Hello, my dear students. My name is MS Abdul Rasool, lecturer in chemistry in Vignan Cooperative Junior College, Vadlamudi. Today we are going to start ethers chapter. This ether chapter, after alcohols, phenols, then ethers. In this chapter, the contents are introduction about the ethers, nomenclature of ethers, structure of functional group, preparations of ethers, physical properties of ethers, and chemical properties of ethers. So, how many contents are there? There are 6 contents. Any chapter, first of all, we have to explain the introduction about that chapter. After that, nomenclature, structure of functional group of ether, preparation of ethers, and physical properties of ethers and chemical properties. Introduction of ethers. What are the ethers? Ethers are hydrogen atom, substitution of hydrogen atoms and hydrocarbons with alkoxy or aryl oxy group are called ethers. The substitution of hydrogen atoms and the hydrocarbons with alkoxy or aryl oxy group are called ethers. For example, I want to write hydrocarbon like this. Then this hydrogen is replaced with alkoxy group. Alkoxy group. This in place of hydrogen, then I substitute alkoxy group, or hydrocarbon is in the hydrocarbon hydrogen atom is substituted by aryl oxy group. Aryl oxy group ROAR. This is the what compounds. So substitution of hydrogen atom with alkoxy or aryl oxy are said to be what ethers. Ethers general formula is CnH2n plus 2O. This formula is similar to that of monohydric alcohols. Monohydric alcohols. These ethers are alkyl substituted derivatives of alcohols, phenols, and dialkyl substituted derivatives of water. Suppose to say ether general formula ROR. Here alkyl groups are substituted in the water molecules. 2 alkyl groups are substituted. Right? Understand? Suppose you have to take alcohol. So here H, in place of H, R group is substituted. Then you will get here ROR. That means alkyl substituted alcohols. Suppose you have to take phenols. Phenols alkyl group is substituted. Then we can get here ethers. So ethers are named as what? Dialkyl substituted derivative of water. Water, you know formula H2O. In the case of water, 2 hydrogen atoms are substituted by alkyl groups, and in the case of alcohols, hydrogen atom is substituted with the alkyl group. In the case of phenols, hydrogen atom is substituted with the alkyl group. These are the what? Alkyl derivatives of alcohols, phenols, and dialkyl derivatives of water are said to be ethers. Ether general formula we can write it as ROR. R indicates alkyl groups, right? Example for ether is first ether CH3 OCH3. Right, understand? The CH3OCH3 is the dimethyl ether. Dimethyl ether. Right, understand? And C2H5OC2H5. This is the water diethyl ether. Dimethyl ether, first one. Second one is diethyl ether. So these are the water ethers. Next, let us we discuss about the ethers, classification of ethers. Ethers classification. Ethers classification. Classification of ethers. Classification of ethers. Ethers are classified into four types. Number one is symmetrical ethers. Symmetrical ethers. I will take the example for symmetrical ether. Dimethyl ether. Dimethyl ether. Dimethyl ether formula CH3OCH3. In this ether, both alkyl groups are identical. Both alkyl groups are identical. Then the ether is said to be what? A symmetrical ether. Let us take the example number 2. Example number 2 is diethyl ether. Diethyl ether. Diethyl ether formula C2H5OC2H5. In this case also both alkyl groups are identical. So ether which contains two identical alkyl groups are same, then the ether is said to be what? A symmetrical ether. Next, second one is unsymmetrical ethers. Unsymmetrical ethers. Unsymmetrical ethers. That means the ethers in which both alkyl groups are different. I want to take example number 1. Methyl propyl ether. Methyl propyl ether. Methyl propyl ether. In this compound, the formula is CH3OC3H7. What is the difference between these two symmetrical ethers and unsymmetrical ethers? In the symmetrical ether, both alkyl groups are same. And the unsymmetrical ethers, the both alkyl groups are different one. Right, understand? So if ether consists of two different alkyl groups are said to be unsymmetrical ethers. Right, understand? Let us take C2H5O C3H7. This is the ethyl propyl ether. Another example. Here our group is ethyl, here our group is propyl. So both alkyl groups are different. Then the ether is said to be unsymmetrical ether. Third type of ether is aryl ethers. Aryl ethers. Aryl ethers. Aryl ethers example C6H5 OC6H5. This is the diphenyl ether. Diphenyl ether. This is the third type of ether. Both groups are aryl groups. Then we can say the ether is said to be aryl ether. Next, fourth one is phenolic ethers. Phenolic ethers. Phenolic ethers. In the phenolic ethers, one is the phenyl group like this, and second one is the alkyl group. One R is the aliphatic alkyl group. Second R is said to be aryl group. This is the mixed ether. This is said to be phenolic ether. So ethers are classified into how many types? Four types: symmetrical ethers, unsymmetrical ethers, aryl ethers, and phenolic ethers. In the symmetrical ethers, both alkyl groups are same or identical or said to be symmetrical ethers. Right? Understand? And the second one is unsymmetrical ethers. Unsymmetrical ethers means the ether which consists of two different alkyl groups. Two different alkyl groups are called unsymmetrical ether. So, example methyl propyl ether is the example. Second one, ethyl propyl ether C2H5OC3H7. Next, third type of ethers are aryl ethers. In the aryl ethers, both groups R groups are aryl groups. So, diphenyl ether we can say example. Next, phenolic ethers. Phenolic ethers means what? One alkyl group is aliphatic alkyl group and another one is the aryl group. Right? Understand? So this name is the compound is Anisole. Anisole. Anisole is the example for phenolic ethers. This is regarding about the classification of ethers. Right? Understand? Nomenclature of ethers. Nomenclature of ethers. This ethers nomenclature is done in two ways. Number one is common names. Common names. Common name system. Common name system. In the common name system, ethers are named as alkyl ethers. Alkyl ethers. Alkyl ethers. Right? For symmetrical ethers. For symmetrical ethers, we can say it as alkyl ethers. But alkyl ethers. Alkyl ethers name is given for unsymmetrical ethers. Unsymmetrical ethers. Right? Understand? So let us take the example for symmetrical ether. CH3OCH3. CH3OCH3. Both alkyl groups are same, identical. Then we can say alkyl ether. Two alkyl groups are there. The alkyl group is methyl. Hence we can say dimethyl ether. Dimethyl ether. Dimethyl ether. Right? Understand? Let us take the another example C2H5OC2H5. This is also symmetrical ether. Right? This symmetrical ether name is diethyl ether. Diethyl ether. Right? Understand? Let us, I want to take one more example for unsymmetrical ether. Unsymmetrical ether. Unsymmetrical ether. Unsymmetrical ether is CH3OC2H5. Here there are two groups are there, alkyl groups. Which alkyl group we have to write first? In the case of this one is ethyl, and in this case is methyl. In the alphabetical order, ethyl comes first, methyl. So we can say the name of this compound, common name is ethyl methyl ether. ethyl, methyl, ether. Right? Two alkyl groups are there, alkyl, alkyl, ether. For what case? For unsymmetrical unsymmetrical ethers. Right? And one more example I want to write, ethyl propyl ether, C2H5O C3H7. In this case also, which alphabetical order is comes first? Alkyl group ethyl. Ethyl comes first. Therefore, first of all, we have to write first ethyl group which comes first in the alphabetical order, ethyl. Second one is the propyl ether, ethyl propyl ether. Right? Understand? This is the way to give the nomenclature, common nomenclature for ethers. Let us go to discuss about the IUPAC nomenclature of ethers. Students, we discussed about the common nomenclature of ether, common names. But in the IUPAC system, IUPAC means what? International Union of Pure and Applied Chemistry. According to IUPAC system, ethers are named as alkoxyalkanes. The name of ether in the IUPAC system is said to be alkoxyalkanes. Let us take the example number 1. Here examples. Here this one is methyl, and this one is what? One part is said to be what? Alkoxy part, and another part is said to be what? Hydrocarbon part. Alkoxy part. This one is the what? Alkoxy part, and this one is the what? Alkane part. So what is the alkoxy group is there here? Methoxy. CH3O, methoxy. Longest chain contains only one carbon. Then we can say its name as what? Methane. Methoxy, methane is the IUPAC name of CH3O CH3. Right? Understand? And this one, in this case, this is the first part of the compound is said to be what? Alkoxy part. Then I can write ethoxy. Why it is ethoxy? Because two carbon atoms are there. Ethyl plus oxy, ethoxy, and longest chain contains two carbon atoms. Then ethoxy ethane. We can write the name of this compound. Then take the third example. In the third case, so longest chain is the what? Hydrocarbon part, and the smallest chain is said to be considered as the alkoxy part. So this is considered as a what? Alkoxy part, that is the methoxy. Where is the position of methoxy? We have to mention it. This is the what? First carbon, second carbon, and third carbon atom of the longest chain. So I can write this one, 1-methoxy propane. Why we can say propane? Because longest hydrocarbon part consists of 3 carbon atoms. Hence, propane should be used, and single bonds are also there. Then last compound here, C6H5OCH3. This is the what? Methoxybenzene. We can write it. Methoxybenzene compound. This one common name is also there. This one is anisole. Anisole is also considered as a IUPAC name, accepted by IUPAC, right? Understand? And we'll take this compound. In this compound, this is the what alkoxy part, and this one is the hydrocarbon part. So ethoxybenzene, 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 right? So for this one, this is the alkoxy part, this one is the what alkane part. For alkane part, I have to give the what numbering 1, 2, 3. So methoxy is there. First of all, we have to write methoxy. Methoxy, where it is there? 2 methoxy. Why it is 2? Because the methoxy group is attached to the second carbon atom of the longest chain. 2 methoxy propane. 2 methoxy propane. This compound named as 1, 2. But we have to follow the least sum rule. According to least sum rule, this one part is the what ethoxy group, 2 ethoxy, 1 comma 1 dimethyl, 1 comma 1 dimethyl ether, dimethyl ether, no D to say, cyclohexane, we have to say it, cyclohexane, cyclohexane, right? Understand? And this compound is here longest chain. You have to consider this one. 2 carbon atoms are longest continuation chain. So one position there is a methoxy group, second position is also methoxy group. So 1 comma 2 dimethoxy, 1 comma 2 dimethoxy ethane, 1 comma 2 dimethoxy ethane. These are the examples. We are going to classify the nomenclature of IUPAC system. Alkoxy alkane is the IUPAC name of ethers. So first part is said to be alkoxy part, second part is said to be alkane part. Alkoxy alkanes, methoxy methane, ethoxy ethane, 1 methoxy propane. Why you have to say use one position of methoxy group? I have to discuss it. And this one is the what? This is the hydrocarbon part. This one is the alkoxy part, right? So hydrocarbon part is the what? Benzene ring, benzene substituted derivative. Hence it is said to be what? Methoxybenzene, methoxybenzene. The common name for methoxybenzene is anisole. Okay, students, the nomenclature of cyclic ether. Cyclic ether means the cyclic in structure. That means ether, oxygen added to the first carbon and the last carbon in the compound are said to be what? A cyclic ether. In the cyclic ethers, the cyclic ethers are known as what? Oxyranes. Oxyranes. This is the what? CH2 single bond CH2O. This is said to be what? Oxyrane. This oxyrane is also named as epoxy ethane. Here 1, 2 carbon atoms are there. 2 carbon atoms are there. Eth plus N, ethane. And epoxy is there. The oxygen which is joined with the 2 other carbons is said to be what? Epoxy. Epoxy ethane. Let us take the second example. In the longest chain is there. Longest chain. Longest chain is numbered as 1, 2, 3. Here 1 comma 2 epoxy propane. Why we can say propane? 3 carbon atoms are longest ring. There we can name it as oxyrane. This part is what? Oxyrane. The second carbon has what? Methyl group. So that 2 methoxy oxyrane. 2 methoxy oxyrane. Next, second one is the what? Third example is 2 comma dimethyl oxidane. 2 comma dimethyl. 2 methyl here. 2 methyl oxidane or 1 comma 2 epoxy propane. Third example is CH3CH single bond CH single bond CH3. Here numbering of the carbon chain from left to right I have to give 1 2 3 4. At the second and third position there is a oxygen linkage, so we can say 2 comma 3 epoxy. Total number of carbon atoms in the chain is said to be 4, hence we can say 2 comma 3 epoxy butane or 2 3 dimethyl. This one is the methyl and this one is also methyl. 2 comma 3 dimethyl oxidane. 2 comma 3 dimethyl oxidane. This is the nomenclature of ethers. Ethers nomenclature. First one is the common nomenclature, common names of the ethers. Second one IUPAC names. IUPAC names is the alkoxy alkanes. And third one is cyclic ethers. Cyclic ethers are also known as oxidanes. These oxidanes, if 2 carbon atoms are there, 1 oxygen atom linked with 2 carbon atoms, then we can say it is oxidane. Right, understand? So there is a substitution at this position or this position. So here 2 methyl oxidane or 1 comma 2 epoxy. Epoxy is there. That means oxygen linkage between the 1 and 2 carbon atoms. So that 1 comma 2 epoxy propane. Longest chain contains 3 carbon atoms. Right, understand? And here also 4 carbon atoms are the longest chain. It is second carbon atom and third carbon atom attached with the oxygen linkage. Cyclic linkage is there. Cycle is completed through oxygen. Then we can say 2 comma 3 dimethyl oxidane or 2 comma 3 epoxy. Epoxy, we have to say it. Epoxy means what? Oxygen linkage with 2 carbon atoms of the chain. A 2 comma 3 epoxy butane.